Okay, it seems the technology and I have finally settled in. Good morning, everybody, and it's really good to be back in Khartoum. I'm glad to be here, and congratulations to the STNOG team for pulling off what looks to be yet another successful STNOG event. So Sarah didn't quite, I didn't quite submit this talk. Sarah came to me and said that I need to talk about internet infrastructure. And when I said, what about internet infrastructure would you like me to talk about? She said, well, just pick anything that you like and anything that you think is relevant and going to be useful for the attendees. So for those of you that know me, you know that I have particular favorites that I love to talk about. One of the things that I love to talk about is the DNS. Another thing that I love to talk about is data security and privacy. And I also love to talk about internet exchange points. So we're going to try to mix all three of those into this if they give me enough time. But first I want to tell you a story. I love telling stories. It comes with being African, I think. So my mother lives in an apartment building that was built in the 1960s. So it's about 50 years old this year. It's a nice, solid building. It's very strong. Thick walls. You cannot hear the neighbors, which is great in my case. And because it's such an old building, it had copper pulled into it, well, 50 years ago, right? So it's got copper in there and a telephone line. And although the copper's good enough for a telephone line, the copper's not good enough for high-speed internet access. So for a long time, my mother, in her apartment, could only get DSL access. She could get like 2 megabits a second worth of DSL. And it was through the incumbent, and incumbents generally don't like to give you the best service, so it wasn't really 2 megabits DSL, it was really much worse than that. My mother's not a heavy internet user. She likes to send messages and then receive messages via the instant messaging flavor of the day. And every now and then she likes to watch one of these Bollywood movies, you know, where they go like that. And now and then she starts to stream one of the community stations from where we grew up in the small village. My mom likes to listen to that online. So this is the situation. She's got really bad, in my opinion, internet access. So last year, at the end of the year, the building that they live in upgraded. They finally got fiber to the home. And like the good son that I am, I went and bought a lot of brand new equipment. This is my mother, I'm going to spoil her. So I went and bought a brand new shiny router. I went and got a brand new wireless AP. So my mother has gigabit wireless AP in her home, and all of the nice stuff. And I'm determined to make this work because I'm finally going to prove to my mother that I do not work in a call center. I'm actually a network engineer. So this is the situation. I spend a day working with the technicians. We finally get everything connected and everything's working. So she's got 100 megabits of access. Now think about it, to go from 2 megabits of access, which works sometimes, to 100 megabits on fiber, that's really good, right? So after I've tested everything, because if you know, I mean, everyone here has a mom, right? And you know that you can never, ever, ever satisfy your mother. There's always, but why isn't it blue or pink? Or does it come in 2, even if you don't need it? So after I'm positive that there's nothing that she can complain about, I call her and I say, Mom, come, let me show you something. We've upgraded your internet access. So she looks at me very quizzically. What do you mean we've upgraded it? I said, well, your internet access is going to be 50 times faster. Now it's not. But she doesn't need to know that. She just needs to know it's going to be much faster than before. So I say, Mom, your internet access will be 50 times faster than what it was yesterday. So she starts grumbling about why I've messed the carpet with all the work that I was doing and the cushions are out of place. But eventually she sits down and she says, okay, let's test it. So she takes out her phone. My mother has an iPhone. And what does she do? Well, she does the thing that you'd expect my mom to do. She's 70 years old. She turned 70 just last month. So she starts typing on her phone. She opens up WhatsApp and she's pressing and she's sending a message to my aunt who lives somewhere else. And she's, if you've watched a 70-year-old type, this is how they do it, right? Well, at least how my mother does it. And while she's typing, she tells me, but this internet thing doesn't feel any faster. So I think, wow, I spent the whole day trying to make mom happy, and I'm sure it's working well. But I forgot that her experience of what internet access is like has very little to do with what I think internet access is like. And I thought, is this what I'm doing? Is this what I'm worth? Am I teaching people about building infrastructure? Am I building infrastructure? And the last mile is actually not the copper or the fiber, but it's this on your phone. So I was thoroughly upset. I was dejected. I walked back to my home thinking, fine, well, you know, you can't please your mother, right? 2 days later, my mom calls me. She calls me to come and give me food, of course. I'm a good son. I go to get food from my mother. And she says, by the way, this internet thing is better now. I can watch my Netflix. She watches the Bollywood movies, as I said. And while I'm watching the Netflix, this is how my mother calls it, the Netflix, I can talk to uncle. My uncle lives in a different country, and she uses Skype to communicate with him. And I can listen to the radio all at the same time. I don't know how I'm going to do it, but it all works. So that was happy. That was what made me happy. It was the understanding that in the background, all the sweat, the toil, all the work that we put in to try to make internet infrastructure work actually amounts to something. Because the thing that we do, and stop and think about this for a minute, we work in this very abstract space, infrastructure or IP. You can't see an IP address unless you're, trouble. You can't see RF. But there's got to be a point to it. And the point to it was this. The point to it was that now my mom could connect with with my uncle that was living in Australia. My mom can watch her movies. My mom's experiencing a better quality of life. And for the first time after a long time, I thought, wow, this thing that we're doing, we're not building internet networks. We're building, to borrow a line from the Cisco slogans in the 90s, we're building the human network. And that's why I get excited about infrastructure. I get excited about infrastructure and I get excited about the internet because I don't think of it as just putting together routers and switches and putting together circuits and building things like fancy big networks, because the network's immaterial. It's the human network that matters. So take that for a minute and consider the person sitting to the left and consider the person sitting to the right of you. And if you get nothing else, I think that if you get nothing else out of this SDNOG experience, consider that you've improved your human network experience by simply being here. And for that, I say thank you again to the SDNOG organizers. But now let's talk about internet infrastructure. So, as I said, she gave me open rein and she says, choose something that you want to speak about. And I thought, well, what is the thing that made my mom happy recently? And that's what I'm going to talk about today. But before we do that, since we're all technical people in this room, I want you to remember a very simple formula. I'm going to ask you this a little later on, so let's see who does. Speed times distance equals cost, right? This is much simpler. I can add derivatives and integrals to this to try to make it look complicated and to make it seem like I'm smart, but I'm not, and this isn't. Speed times distance equals cost. And that's a really important concept to consider when we build internet infrastructure. The thing that I want to talk to you about today is coincidentally one of my favorite things. It's something that I spend a lot of my time doing, talking about and improving internet infrastructure, specifically around interconnections. So we have a situation, and some of you probably know all of this, but you have a situation in a country where you may or may not have an internet exchange point. I think everybody here knows what an exchange point is. We've gone through previous exchange point tutorials before, about how it's a meeting place for internet service providers, or internet operators rather, to get together and exchange internet traffic. right? So that's a very simple explanation of what an exchange point is. You get together, across the exchange point, you peer, you move internet traffic between two networks. But I want to explain it from a different perspective today, because when we talk about exchange points, usually what happens is that we start to focus on the technology that's involved in the exchange points, and people start talking about the complexity and the difficulty and how I need to become a better BGP engineer and all of these terms that, while they might be true, they detract you from one very simple thing. How does routing on the internet work? And how does internet exchange points make that better? And that's really the thing that, well, in the short time they've given me, we're going to want to try to discuss today. So, in the situation here, and I hope you can see this, we've got two different networks. We've got network red on the left-hand side, and we've got network green on the right-hand side. No, yes, that's right, sorry, network green on the right-hand side. And here we have a situation where there's a customer in network red, and that's the laser pointer, there we go. Customer in network red that wants to speak to a customer in network green. So in a normal internet network, in a well-designed internet network, how would traffic or how would data move between the networks to complete the network transaction? That's what we're going to talk about here. So we've got network red, and network red wants to send an IP packet to a customer, well, red customer wants to send an IP packet to green customer. Red customer initiates the packet, and the packet gets inside the red network service provider's network, or the red ISP. Now, the red ISP is connected to the green ISP in two locations. It's connected in location, let's call it left, and location right. Location left is pretty close to it. Location left is pretty close to it. Location right is quite a bit away. How many of you remember that formula I wrote out? Only two? Kahua Sudanese? No? Okay, speed times distance equals cost. In any sane network, the thing that a network operator is going to try to do first is to minimize their costs. Now, if you were a network operator, and if you were trying to minimize your cost, right, if you solve for cost in the equation that I gave you, you would try to take the traffic off your network and onto the green network here, because that exchange point is closer to you. And if it's closer to you, it means that it is cheaper to get to that internet exchange point, because the piece of fiber that you need to have from your network to that internet exchange point is shorter. And if it's shorter, well, all things equal, it's going to be cheaper. So network red, if I've got this right, no, I'm going the wrong way. So network red sends the packet that it received to the internet exchange point that is closest to it. Network red interconnects with network green through an act we call peering. Network green receives the packet, and it is now duty bound, well, because we're paying them, right, as a customer. Network green gets the packet, and network green has to take the packet and deliver it to its customer. And that's what it does. It brings the packet along the long path here, as you see here, delivers it to its customer. In this part of the internet transaction, network red had to pay a very, very small part of the cost of the transaction. If you look at the fiber and you try to imagine that there's some sort of cost attached to that fiber, you'll see that this is a much lower cost than that. That's fairly obvious, right? So if you had to think that this was going to be a complete internet transaction, then you'd be inclined to think that in this transaction, network green has lost out, because network green has spent more money to try to get a service to its customer than network red. But fortunately, the internet doesn't work that way. The internet works on the basis of me sending you data, you sending me a reply, perhaps to signal that you've received the data and that you'd like more of it, and then I send more of it. So in this case, we've got the green customer who now needs to reply to the packet that the red customer has sent in. And how does this work? Well, the green customer sends his packet to the green network. The green network accepts the packet, and he's got to make the same choice that network red made just a few milliseconds ago. Do I take that packet and deliver it on the long path, which is perfectly valid? Or do I try to save my money and send that here to the exchange point nearby? So who would want to go to the IX on the left? I'm glad to see that even though it's still so early in the morning, at least for me, everyone's sane. Everybody believes that they can save more money if they deliver the packet to the exchange point that is closest to them. Notice what's happening here. You might think that the decision that the networks are making are based on multiple criteria. They're based on quality of service, they're based on shortest path, they're based on anything that you could think of. But the truth is, the decision that's being made is an economic decision, right? Both networks are making an economic decision on how they believe they should route that packet. So, back to our situation, which we will end very quickly. Network green gets the packet. Network green decides, I need to deliver it, so it delivers it to the internet exchange point that is closest to it. And network red now has to bear the lion's share of the cost in the return packet. And it gets the packet into its network, and it delivers the packet to its red customer. This is a very simple internet transaction. It's been large, it's been simplified, but this is the basis for how most internet traffic works. At some point, your internet traffic does this, okay? In a situation like this, in a situation where you have two internet providers both connecting at two internet exchange points, you get network red, as it was, being responsible for its own costs. So the cost to get to the customer, the decision to say, instead of connecting via copper, we're going to connect via fiber or microwave, all involves expenses. The network operators are here. They're going to tell you that it's expensive to put fiber in. It's not. They're going to tell you that it's expensive to do a bunch of things, but they are not asking other networks to invest in their network, right? Anything that network red has to spend to deliver the packet is pretty much similar to what network green has to spend to deliver its packet. Okay? So this is our ideal situation. I'm an economist, incidentally. I'm not really a computer scientist, nor am I an engineer. So us economists, we like to build perfect situations, and this is a perfect situation. But in a situation like that, there's clear and symmetric sharing of costs, as you can see. This is important. This is important because the efficiency of the internet, the true efficiency of the internet, relies on this simple behavior. The fact that for any two parties who wish to share exchange, for any two parties who want to exchange traffic, there must be a pair of internet exchange points close to each party for the exchange to be equitable, for the exchange to be fair, okay? So what happens if the exchange is not, what happens if there isn't? That's the important question here. We've been spending all this time building a perfect situation, which you now understand, but what happens if the situation is not perfect because we live in this imperfect world? What happens if there isn't two internet exchange points, one close to each service provider? What do you think? Well, let's go back to our picture for a second. Sorry, I keep pressing the wrong button. I'm still pressing the wrong button. If there weren't two internet exchange points here, if network green was always the network that had to cover the larger part of the cost, and network red was always sending traffic down this path, one network would be very, very unfairly disadvantaged. So the message that we want is, and it started out like this, so give me a second while I explain. The message started out like this, that countries that don't have internet exchange points basically disadvantage themselves. Now this is a good idea. It's a good idea to build an internet exchange point. It's a good idea to have a functional, working internet exchange point that encourages the exchange of domestic traffic. But it's a really bad idea to stop there. And the difference between the two slides, if the text is not clear, is that you've got to stop thinking about internet exchange points as some sort of national treasure, as some sort of national resource. And I'm using that word because you often hear it in the texts, in the messages that we get, that there are national internet exchange points. There's no such thing as a national internet exchange point. There's a national government, yes. There used to be a national NREN, I believe. And there are other things where you should only have one in your country. But you don't need, and you should not have just one internet exchange point in your country. So there are about 482 internet exchange points globally. I got this figure as at about this morning. So 482 active. There are about 818 known internet exchange points, ones that have come up and gone down, but about 482 active right now. I live in South Africa, as Ahmed just said. What do you think is the national internet exchange point in South Africa? We've got 6. Pick one. There isn't. There are 89 internet exchange points in the United States. It is the country with the most internet exchange points. There is no national internet exchange point in the United States. The next most country with internet exchange points is Brazil. There are 29 internet exchange points in Brazil. There is no national internet exchange points in Brazil. There are internet exchange points in cities and places that need internet exchange points. And what's the exchange point meant to do? Well, we covered this in previous sessions, in previous workshops, in previous presentations at SD-NOG. It's meant to facilitate that flow of traffic. But as you saw, it's not just the flow of traffic that it facilitates, it helps to keep costs even. And that's a really important thing. So why is this important to you in Sudan? Right? You have an internet exchange point right now. You have the Sudanese internet exchange point, which is housed in Khartoum. And if you have an exchange point, then why am I here telling you you need an exchange point? Well, I'm not. I'm not telling you that you need an exchange point. I'm telling you that you need an exchange point when there are certain characteristics. When you have people that are interacting in this telco space, in this internet space, I should say, where they are transacting, they're sending messages, they're using the internet, right? So if you have a city and there are people in that city that are using the internet, if there's telco infrastructure, if you have more than 3 internet service providers in that city, and of course, you have, well, people, right? People need to interconnect. That's a good place to have an internet exchange point. So in your country, I took a quick look last night, and it's glaringly obvious to me that you should have an exchange point in Port Sudan. You've got a population of over 500,000 people in Port Sudan. You have at least 3 network operators that are happily exchanging traffic, not in Port Sudan, but in Khartoum. So if we were doing this meeting in Port Sudan, and I was on one mobile network and he was on the other, and we were trying to send traffic, all the traffic would come all the way back to Khartoum and go all the way to Port Sudan. That's expensive. The operators in the room, at least 2 of them were smiling at me, but that's expensive, it is. And you can save that by saying, well, how do we get an exchange point in Port Sudan? What's it going to take? What's it going to cost us? And if you're interested, we spoke about this at SD-NOG 2, you can get an exchange point up for less than $1,000. It doesn't need to be this huge monolithic building that has, 27 staff and a budget of $10 million a year. That's all ridiculous. An exchange could easily be done for less than $1,000. Done it. He's done it. He's done it. There are lots of us that have. But more than that, more than just you doing it, let's extend this for a second. You're going to say, and I spoke to the operators this week, my Arabic is still very basic, but I heard Sarah say that during the week we had workshop meetings with the different operators. And that's true. I spoke to the different operators this week. And one thing that the operators always told me was, but the internet traffic is so low. We know that. We know that the internet traffic in Sudan between Sudanese is low. That's not what we're trying to build for. We're trying to build a bigger, better, faster, and cheaper internet. And in doing that, you have to say, how do I eliminate things like unnecessary costs, things like things that are causing detriments in the quality of service that we have. And my example of bringing traffic all the way from Port Sudan to Khartoum to be exchanged here only to be sent back to Port Sudan is just one of those. When the traffic could be exchanged faster, cheaper, and with better quality of service in Port Sudan. You're doing this internally, but what about externally? Who here, with the exception of him and him and him, knows where the most fiber cuts in Africa were over the past 5 years? So Africa's got lots of submarine fiber now, right? And there have been lots and lots and lots of submarine fiber cuts over the past few years. So over the past 5 years, can you take a guess which city in Africa, which it's a port, so you don't have to spend too much time thinking, which port city had the most fiber cuts attributed to it? I'm not saying that they cut the fiber. I'm saying that there's a city, and nearby the city, there are fiber cuts. Who wants to take a guess at where it is? It's not Khartoum, clearly, because you're inland. It's not Johannesburg, because you're inland. Egypt, Alexandria. So this is a map of some of the fiber infrastructure, and apologies, I see it's not too clear, but most fiber cuts have been happening in this part of the region. The region after the Suez. I'm here today to tell you that as an internet infrastructure builder, if I was sitting in your shoes, if I had some sort of financial backing or legislative backing or any backing like that, I would be seeing a fantastic opportunity here. That you could create an area before the Suez, that area where all the fiber cuts happen, you could create an area here, some sort of special economic zone. You could have an internet exchange point that works for you, the domestic operators. You could encourage foreign operators to connect to your internet exchange point as well. The foreign operators would love to do it. Why? Because they're not going to risk their IP traffic going up and getting cut after the Suez. It's going to make it faster and cheaper for them to change traffics with networks that are coming up from Africa that may now decide to stop in the special economic zone if you so created it. Okay? But more importantly than all of that, the minute a foreign operator decides to put operations on your soil, what happens is that for you to send packets to that foreign operator's network, you no longer pay for any of that. Because you're just paying the cost as an operator, as in somebody that's connecting to the IX, you're just paying the cost of getting from your network to the operator, which is now inside Port Sudan, which is going to cost you next to nothing. So you end up saving money. Who here likes to save money? Okay, so the rest of you earn way too much. All right, clearly. So this is an opportunity. When Sarah said talk about infrastructure, I thought, well, for me, a fantastic internet opportunity for you in Sudan would be to say, how can we create this thing in Port Sudan that will immediately add to my economy? They're telling me that I have to move on much faster because we're running out of time. So I'm going to stop this bit for now and continue. Wrong way. But internet infrastructure needs, well, there are various cycles in the internet infrastructure bit that you would need to consider. So far, we've been discussing the internet exchange point. The internet exchange point is critical. It's the heart to the things that you're going to build inside your economy. But it's only one cog in that wheel. There are lots of other elements that you'd need to consider. So aside from just upgrading internet infrastructure, you'd also need to think about things like the local loop. And here I'm not talking about my mom's finger when she's pushing on the phone. I'm talking about how do you get people connected to the internet inside your country, right? So 4G, fiber to the home, those sorts of high bandwidth technologies need to be made available to people so that they can take advantage of things on the internet, but also so that you can hit this fantastic thing that us economists like to call economies of scale in infrastructure. Deploy fiber, get economies of scale, suddenly the price goes down for everybody. And that's what we want to get to. You also need to think about building and upgrading national backbones. I think national backbones are easy to understand. International cables need to be encouraged to land. You've got 3 already, that's a good start. You need to have better access to critical infrastructure. And critical internet infrastructure are things like DNS routes in your country. Now you're lucky, again, because until a short time ago, you had 2 DNS routes in your country. And as the exchange points start to grow and develop, you can start pulling in more of these critical resources into your country. Oops, wrong way. And of course, to tie all of this in, the thing that the techies hate, but you do need to have some sort of policy, regulation, and governance to make sure that you're heading in the right way. It takes about 2 years or so to go through this, 2 to 3 years to go through this entire cycle, right? And every 2 to 3 years, all of this doubles. Now, this doesn't mean that in 2 to 3 years you need to double the amount of regulation. It just means that you need to be aware that the requests that you're getting, the infrastructure flow that you have, what you're building for is going to, or what you're regulating for, is going to be twice this in 2 years. As I said, after that, it starts all over again, and I don't know how to stop this. So. I've provided a critical infrastructure checklist. This is no news because it's an old checklist. And the reason I put it in here, even though it's something that we had spoken about before, is because there's still elements here that you'd want to get done. So if you're sitting in here and you're from the SIS or the .SD, this is a shout out to you. This is still not done. And there's really no good excuse for that, absolutely no good excuse. Philip is very disappointed with you. He sat and taught you how to do it. The policy and regulatory checklist as well, you can look through this. As I said, I provided it as a reference material. My time is up, and I think we're doing questions after the talk. Okay, so thank you very much. Shukran jazalan.